Welcome to The Explainer. Today we're taking a really fascinating journey, one that basically bridges the gap between the crazy physics of flight up in the air and your totally practical, everyday safety responsibilities down on the tarmac. You know, if you're a student pilot, or even just a huge aviation nerd, understanding how an airplane moves, well, that's only half the battle. The other half is making absolutely sure the aircraft is actually safe to leave the ground in the first place. So we're going to connect the aerodynamic theory of control surfaces directly to your pre-flight inspection training. Okay, let's take a quick look at our flight plan for today. We're covering 1. The 3 axes of flight. 2. Primary flight control surfaces. 3. The pre-flight walk-around. 4. Inspecting the control surfaces. And finally, number 5, how checklists ensure flight safety. But before we get into the actual mechanical parts of an airplane, I want you to just stop and think about this for a second. How does a pilot actually steer up there? I mean, unlike driving your car on solid pavement, an aircraft is operating in a 3-dimensional fluid. It's completely free to rotate in literally any direction. So to master the sky, you've really got to master these invisible dimensions of movement first. Which brings us to Section 1, the 3 axes of flight. Let's talk about these invisible forces. First up, we've got pitch. Imagine a line passing right through the aircraft, literally from wingtip to wingtip. We call this your lateral, or transverse axis. When the airplane rotates around this imaginary line, the nose points either up or down. And this pitch movement is what basically allows the aircraft to climb up into the sky, or descend back down toward the earth. Next up is roll. This is rotation around the longitudinal axis. So picture a line running straight from the nose of the plane all the way back through the tail. What's truly wild is how rolling actually functions in practice, because here is the absolute secret to flying. Unlike driving, you don't turn a plane primarily by just pointing the nose left or right. Nope. By banking the aircraft, you're actually tilting the lifting force of the wings in the direction you want to go. That horizontal component of lift, that's what truly pulls the airplane through a turn. It's brilliant. And finally, we have yaw. Imagine a vertical pole driven straight down through the dead center of the aircraft, from top to bottom. Rotation around this vertical axis is yaw, which moves the nose left or right. But, like we just talked about, an airplane is definitely not a boat. You don't use yaw as your primary way to change direction. Actually, scratch that. It's more like yaw is incredibly important for keeping the nose perfectly aligned with your flight path, and for countering the drag that it's created when you roll. Moving right along to Section 2, primary flight control surfaces. Let's translate those invisible axes we just talked about into physical parts, the stuff you'll actually be moving from the cockpit. So the crucial takeaway here is that each axis of motion is commanded by a very specific aerodynamic device on the wings or tail, and those devices are linked straight to your controls. To control your roll, you turn the yoke left or right, which moves the ailerons. To control your pitch, you push or pull the yoke to move the elevator. And for yaw, well, you press the floor pedals with your feet to move the rudder. Let's look a little closer at how these surfaces actually generate force, because ailerons and elevators function totally differently. Ailerons, which sit out on the outer trailing edges of your wings, move in opposite directions. Turn the yoke left, and the left aileron goes up to kill some lift on that wing, while the right aileron goes down to increase lift. Boom, the plane rolls. Elevators, on the flip side, are back on the horizontal tail structure, and they move up and down together. When you pull back on that yoke, both elevators go up, it pushes the tail down, and pitches the nose right up into the air. Then we have the rudder, hanging out on the vertical stabilizer at the tail. And remember, the rudder is all feet, no hands. You step on the left pedal, the rudder deflects left, pushes the tail to the right, and that yaws the nose left. Now, as a student pilot, you're going to learn real quick that using the ailerons to roll creates this annoying thing called adverse yaw. Basically, the nose wants to swing the totally wrong way because of drag, so you use those rudder pedals to counter it. That keeps your turn smooth, coordinated, and keeps you from skidding sideways through the air like a car on ice. All right, Section 3, the pre-flight walk-around. Time for the visual inspection. Let's get out of the classroom, head down to the tarmac, and see how this theory translates into your most critical responsibility on the ground. Because, let's be real, knowing how the controls work in the air means absolutely zero if they are broken on the ground. It is a non-negotiable, fundamental rule of aviation. Literally no flight begins without a walk-around inspection. Before you even let the thought of starting that engine cross your mind, verifying the airworthiness of your aircraft through a physical, visual inspection is absolutely mandatory. Out there, you are the final line of defense. A proper pre-flight is super methodical. You're always following the manufacturer's specs right out of the pilot's operating handbook, the POH. You're visually checking fuel tanks and oil to make sure they're at the right levels. You're training a tiny bit of fuel to check for water or dirt, because trust me, water doesn't burn too well when you're 1,000 feet up. And of course, you're looking for any missing parts, little nicks, or just general damage to the airframe. Section 4, inspecting the control surfaces. This is where theory completely meets practice. We're going to dial in this pre-flight inspection specifically on those primary flight controls we were just talking about. Okay, so when you're doing your walk around and you get to the wings and the tail, you can't just look. You have to physically interact with these surfaces. Step 1, pull off any external control locks or gust locks. Those are just there to stop the wind from banging the surfaces around when the plane is parked. Step 2, get your hands on them. Physically move the ailerons, the elevator, and the rudder. You are feeling for totally free and smooth movement. Are the hinges catching? Is there some kind of weird grinding sound? And step 3, carefully look over the skin of these surfaces. Any nicks? Dings, structural damage. I mean, these parts take immense aerodynamic stress up there, so even a tiny bit of damage is a massive red flag. Actually, there is this great quote from our source material that perfectly hits the nail on the head. It says, "It's super hard to climb out on top of the wing and look over something after you're airborne." It's kind of funny, sure, but the reality behind it is deadly serious. If an aileron is jammed up, or maybe an elevator hinge is cracked, finding that out while you're barreling down the runway, or worse, climbing through 500 feet, yeah, that is literally a pilot's worst nightmare. You absolutely have to find it while you're still on the ground. Which leads us nicely to Section 5, checklists, ensure flight safety, the ultimate memory aid. Let's look at the one tool that pretty much guarantees you will never miss a step during that walk around. You know, checklists have been the absolute bedrock of pilot standardization and flight deck safety for decades now. They are the ultimate backup brain. Look, we're all human, right? We get distracted, we get tired, we get complacent. A checklist ensures you aren't just relying on your memory, so that totally critical stuff, like making sure your elevator actually moves freely, is never, ever forgotten. And that pre-flight inspection, it's really just the very first item on a massive list of flight phases that all demand their own dedicated checklist. You've got them for before engine start, for taxiing, taking off, cruise, descent, landing, the whole shebang. The discipline of aviation doesn't start when you fire up the engine. It starts with that walk around, and it doesn't end until the engine is completely shut down and secured. Now here is a super critical piece of advice if you're a student pilot. Checklists are not just do lists, okay? It is not a script that you blindly read off to tell you what to do next. Instead, you do the proper actions from memory, like checking your ailerons and rudder, and then you use the checklist to quickly verify that yes, all those necessary tasks were actually completed. The emphasis is always on the check in checklist. It's verifying that your physical inspection was actually as thorough as it needs to be. So we've walked through the physics of pitch, roll, and yaw. We've mapped them right to your elevators, ailerons, and rudder. And hopefully we've shown exactly why verifying their condition on the tarmac is completely non-negotiable. Because every single time you rotate off that runway, your life and the lives of anyone flying with you depends entirely on those aerodynamic surfaces working flawlessly. So the next time you walk out to an aircraft, ask yourself, are you really ready to check them? Thanks so much for joining me on this explainer, and I'll see you out on the flight line.